And we'll try another example. This example is not too difficult, but the one that we'll do after this will challenge us a little bit more. So what do we look at here? How would this thing get simple by the application of assigning u and dv? Well, if I let u be x, then du would just be dx. So that would be simpler. Now everything else, if u is x, everything else has to be dv. So dv would be e to the x plus 1 dx, which would make v equal to, and so I just take the indefinite integral here and the indefinite integral here, and this will be e to the x plus 1. Now, if you don't see that immediately, this can be a sub-problem, and you can use integration by substitution, and you'll see that what I've written is exactly right. So where are we now? I, then, the original integral, I'll put a little I up here to remind us, I is equal to uv, so I'm looking above and to the right, and I see that u is x, and v is e to the x plus 1, uv minus the integral of v e to the x plus 1 du, and du I see is just dx. So this is equal to x e to the x plus 1 minus, and what's the integral of e to the x plus 1 dx? Well, you just solved that problem right up here, and it will be e to the x plus 1 also. Now I think we'll do a little algebra on this, and I can factor out an e to the x plus 1, and what will be left would be x minus 1, and since it's an antiderivative, it's a member of the family of antiderivatives, we add the c on the end of it. So I'm going to claim that this is an antiderivative of this piece right here. And to see if I'm correct, let's check it. And our check, real simple, we have to take the derivative of e to the x plus 1, x minus 1, plus c dx, and see if we get this piece right here, which we would call the original integrand, and we'll see if that's what we get. Alright, what do we have? Well, I'm looking inside the braces here, and I see that I've got a sum, and the left-hand member of the sum is a product, and so I'm going to use the product rule for differentiation. And of course the second member of the sum is a constant, so that's going to differentiate to 0. So it's the first, e to the x plus 1, times the derivative of the second, which would just be 1, plus the second, x minus 1, times the derivative of the first, and that would be e to the x plus 1, and then plus 0 for the constant, equals, alright, let's see what we can do here to kind of clean this up. I can factor out an e to the x plus 1, and I'm left with, well, here I'm left with a 1 plus x minus 1, and that's a 1 and a minus 1, so this is x e to the x plus 1. Is that what I expected? It is, and so the check is okay. Now I said that we would look at something that was a little more complicated. In fact, I think let's clear the screen. All right, so now we want to look at the integral, natural log x e to the x dx. Complicated looking integral. And if we would think about substitution, it doesn't look like I've got a composition. It does look like a composition, but I don't have the derivative of the inner function, so that's not going to work. Integration by parts. That doesn't look real promising either. And so after I've thought about that for a little bit, I will realize that I've got the log of a product. And the log of the product is always the sum of the logs. And so this could also be written as the integral natural log x dx plus the integral of the natural log e to the x dx. And I guess I could put parentheses around that for you. Well, this is looking more promising. What's the natural log of e to the x? Well, let's see. The natural log of anything is the exponent you have to put on e to get the anything. If the anything is e to the x, what do you have to put on e to get e to the x? Well, just x. So this is equal to, I'm going to give myself a little more space here, equal to, not going to change this one right now, natural log x dx plus the integral of x dx. That integral is real easy. This integral, I think I now can use parts and evaluate this integral. So just the integral, see, we've got all these colors, we might as well use them. Just this part right here we'll work on, and then we'll finish this one here up. So let's let u be natural log x, and then du would be 1 upon x dx, and dv, if u is log x, dv's got to be everything that's left, and so that's just going to be dx. So v is equal to x. So now I can rewrite this integral as uv, so that's x natural log x, uv minus the integral of v du, 1 upon x dx, and then don't forget we got this piece out here, and let's just go ahead and do that. What's the integral of x dx? That's a power function, so that would be x, increase the exponent by 1, divide by the new exponent. And eventually I'm going to have to add a c, but I'm going to hold off on that for a second. Alright, so I've got a couple pieces of this already done. I've got x natural log x minus, now can you evaluate this integral? It's an x times 1 over x, and so that's just 1, so it's the integral dx, and that gives me just x plus x squared by 2, and then of course plus a constant. So that's what I think an antiderivative of log x e to the x would be. Am I right? Well, what do? As always, we check. So here's our check. I have to take the derivative of x natural log x minus x plus x squared by 2 plus a constant with respect to x. And if in fact this is the antiderivative, when I differentiate this, I'm going to get log x e to the x. So, well, a good thing we've already studied derivatives and we know how to take derivatives. So what do we see? We've got a sum and difference, and we know that the derivative of the sum and difference is the sum and difference of the derivatives. And I've got a product here, and then just a couple power functions here. So this shouldn't be too bad. So I'm going to do it a piece at a time. We'll start right here. And the derivative of the product x log x is the first times the derivative of the second plus the second times the derivative of the first, and the derivative of x is 1. Now minus the derivative of x, so that's a 1, plus 1/2, and then the derivative of x squared, which would be 2x to the 1. Reduce the exponent by 1 since we're differentiating, and the derivative of a constant would be 0. Now we'll clean up the algebra and see what we've got. X, 1 over x, that's a 1, plus natural log x minus 1 plus, and it's 1/2 times 2, so that's a 1 times x is an x, and then the 0 we don't have to write down, and that's equal to, well, here's a positive 1 and a negative 1, and so I'm left with x plus natural log x. Well, compare that to up here. You know, that's not what I expected, but wait, there's more. So what is x? Well, we decided somewhere right here that natural log of e to the x was x, and so x is equal to natural log e to the x. So that's just replacing this x by a log version of x, plus natural log x, and we know that the sum of the logs is the log of the product. So this would be using elementary logarithm properties, would be the log of x e to the x, and that is where we started, so the check is okay. See you next time.